I'm Robert Hoddebach. I've been working in this company for 13 years. I pretty much grew up in this company. I've been in different managerial roles in 3 different countries. And I'm proud to be the Global Business Line Director of Land Asset Integrity at this moment in time. It's all about the landscape of our clients and how they are coping with the challenges that they have with aging assets and retiring employees, and how we contribute with our geodata solutions to support them in facing those challenges. Land asset integrity covers the sectors of energy and infrastructure. We specifically work for utilities, railroad companies and road authorities, but also for processing environments and refineries. We reinvented ourselves from a commodity business 5 years ago to a solution-driven business now. Most prominent in that is Roam's acquisition and Roam's technology, which makes use of the latest and greatest technologies in machine learning and remote sensing technologies. Utilities are faced with an existential challenge. They're confronted with energy transition, and it means that their network and the distribution networks need to be changed and need to alter to the demands of the future. And what Roam's does is provide a baseline for a grid modernization program. On top of that, it mitigates bushfires by understanding how forest and vegetation is encroaching on the network. We support transport networks, for example with our ARAN and RILA technology. When we use our ARAN technology on roads, that road will be safer, that road will be fuel efficient. Also on the RILA side, we are reducing the amount of people that we need in the rail corridor, thus increasing the safety, but also reducing the disruptions to the community. The future of the land asset integrity business is dependent on how our clients are dealing with maintaining and repairing their critical infrastructure. This is true for established economies, but also in emerging economies like India, we see that need developing at the moment. It's all about how we mature our digital asset management solutions together with our clients to eventually become the geodata specialist for asset owners and operators.
In this section, we would like to introduce RILA to you. RILA is short for Rail Infrastructure Alignment Acquisition System. Please watch the introduction video.
Fugro Rail Data provides essential infrastructure information for rail professionals. We help to build a better understanding of existing rail assets to optimize your planning, design, construction, and maintenance of infrastructure. Our unique Rail Infrastructure Alignment Acquisition Platform, RILA, is a safe, fast and affordable way of delivering accurate, up-to-date information and analysis with no disruption to train service. RILA provides millimeter accuracies in measuring absolute track position, track geometry and the wider rail corridor above and below the subsurface. Creating the ultimate form of geointelligence, Fugro Rail Data is bringing the 3D railway environment to your desktop. Value inputs and financial returns of survey data become more evident in rail asset management. A constant supply of accurate, reliable data improves decision-making, all without disruption to train services and without the need to send staff on or near the track. Information is delivered to our clients via our web-based RILA portal, where clients can remotely view, inspect and analyze assets and provide inputs to asset management and engineering operations. Rail engineers use our 3D information to gain insight about all relevant rail infrastructure assets. This enables accurate work preparation and design decisions based on up-to-date data. This improves safety and efficiency, leading to higher quality work with faster delivery times. Fugro Rail Data provides the smart technology and logistics solution that can power your rail asset management systems with accurate, up-to-date rail infrastructure and geotechnical information with no disruption to train service.
The products of RILA are track position, track geometry and condition, 3D point clouds, and so on. Let's have a look at an example of track geometry and condition monitoring. In the project Amsterdam to Eindhoven, we measure the track geometry every month, mounted on passenger trains. The results shown here is the track quality. The horizontal axis is the mileage, and the vertical is the time from old to new. The track quality value is based on the standard deviation of track longitudinal level and color-coded. The red color indicating poor quality and the blue indicating good. Here we see the track at 20.7 degraded from August to November 2018 until a maintenance performed in December 2018. After that, the track kept stable. However, the track at 21.9 was also maintained in December 2018. However, it kept degrading and became even worse after 1 year of maintenance. Also, we can analyze how track degrades in the whole section. Here, we see 2 times of track maintenance, but which one is better? This is the maintenance evaluation. And how will the track degrade in the future? This is the degradation prediction. Both of them are crucial questions for track owners like ProRail. The track degradation algorithm will be studied using machine learning method by Karim, who is a master student from TU Delft, starting his internship at Fugro this August.
In the next section, we would like to introduce you to Symmetry, a versatile, user-friendly 3D data visualization and analysis platform. At Fugro, we have already been using Symmetry in various ways to serve our clients, for instance by supporting them with their emergency management services. Symmetry started because a large majority of our clients in land asset integrity had the same primary pain points. They had various data types in disparate platforms. They lack proper communication channels to reach the public, teams had limited access to data, and a synced system to collaborate utilizing the data did not exist. How could we address this need? Our clients routinely have a lot of big data, and nearly a quarter of them leave it sitting on the shelf. But if they had the data managed properly, they could rely on it to make better decisions. And so Symmetry was born. What is Symmetry? It's a 3D modeling platform designed for GIS-enabled data management, visualization, and communications. With Symmetry, we're moving beyond the traditional pixels, stats, and graphs. We are providing a 3D ecosystem for GIS-related analysis with all available data sources in a single platform. Because Symmetry is intuitive, both novice and skilled users can make more informed decisions, better manage their assets, and protect life. Now let's show some examples how we use Symmetry to support our clients with their emergency response services. To test the static water level rise, we created a flood event around the city of Austin, Texas, and compared this against the 100 and 500-year floodplain model. Our simulation matched nicely with the flood limits provided by FEMA. The flood simulation in Symmetry works nicely with the existing LiDAR data and 3D models for displaying the impact these floods will have on the environment and community. A future Symmetry development would be to utilize the water level tool connected to tide or flood gauges for real-time water level simulations. The fire response simulation provides a meaningful representation of a fire scenario. This provides a platform for planning and training of emergency response situations and the time it would take to respond to that event. Here you see a simulation of a building fire where we can include smoke, and then we've added weather conditions so you can see the directions of the smoke. In this video, we show how we can simulate the time it would take for an emergency vehicle to leave the fire station, travel a specific route at a predetermined speed, and the amount of time it would take to respond. The responders consider this while planning city events where street closures may be required. The collapse zone tool was created to assist first responders with simulating a structural collapse or help with decision-making during a fire. The tool was created while observing a report of a building fire in Washington, D.C., where the responders needed to set a perimeter of 1.5 times the height of the building in case it collapses. Our developers were able to quickly create this tool to help identify the roads to close, the neighboring property owners to alert, and the first responders to identify safe areas for response personnel staging. The floor plan tool was developed by Fugro as a solution for emergency responders to easily connect interior information with 3D models. When complex interior scans aren't available, Symmetry can easily connect to simple drawings to help with situational awareness, planning, or response. The tool allows the user to select a building footprint or create a building outline, identify the number of floors both above and below ground, create the floors, and attach PDFs to each floor. Symmetry allows for easy interaction with datasets that include interior scans, building design files, or building information models. Within Symmetry, the user can seamlessly move from the exterior to the interior and use the walk mode to navigate down hallways. Hopefully, this introduction provided you with some insights in how we at Fugro use Symmetry, a versatile, user-friendly 3D data visualization and analysis platform, to provide our clients with insights into their 3D geodata.
Super. Well, that was also an impressive video by Fugro. We'll have here 3 people from Fugro. We have Justin, Stefan, and Wouter that are ready to take your questions. If there are any questions in the chat box, please. Yes, there we are. Peter van Oostom, a professor in our university, is asking the question. In Ryla, the data sets also are temporal, repeated scans. How is this used for change detection, deformation, for example, given a large volume of the data, including the point clouds? Is the question clear?
Yes.
And who can answer the question?
Yeah, actually, Symmetry does have some capability to measure things temporally. And with that, we even used it for shadow analysis and everything else, where you can take a presentation and scan it over several days, and you can see how things change. You can present it that way, and such like that. We use that a little bit for shadow analysis. So you can see, for example, how a city would look in the morning versus evening. Sometimes we'll do that for verifying things where you can verify things like whether a solar panel will get enough sunlight at certain parts of the day, things like that. But it does have that capability. We haven't really used it very much, and we're looking forward to other ways where it can be applied. Does that help with the answer?
Yeah, well, thank you very much.
That's. I think that's for Symmetry.
Yeah.
For Ryla, so that's specifically for the real. What we do is we take repeated scans, usually over several months. So the one that we showed from Eindhoven, it's taken over several months, and these point clouds are all stored in the cloud, let's say. So we deliver them on hard drives, we put them in the cloud, and then we process those. And then what we in the end get is per track, per kilometer, let's say. We eventually get a height of where this track is, and then we can we look at a specific piece, say 50 meters, and then we look at standard deviation of the height. And then we can see if it deviates quite a bit. So it's what you saw in the graphs, that's a measurement of how smooth the track is, let's say. So if in these measurements, if the entire track would be lifted, you would not see it. But if it is sort of like a bumpy, rough track, let's say, then that will show in the measurements. And yeah, so and the key is storing this data in the cloud and making it easy accessible that way, that you can quickly retrieve it. But it's the measurements we derive from the so we don't go back to the raw data every time. We save the intermediate results. So it's one time it's a big computation, and the second time it's you use the derived already results and you compare those to the subsequent measurements, let's say.
Okay, very, very good. Well, time is almost running out, but I do have one more question. If there is a student interested in doing an internship or a graduation project for you, what would be your #1 project topic?
Point cloud classification. That one is really big right now, and also image feature extraction from images is also getting big. So we're always looking for people who are interested in analytics and machine learning to help us out.
Okay, thank you very much, students. If you are interested, just join the Fugro channel on Discord and make yourself known to Fugro. I hope you will be around for a couple more minutes, that students are able to contact you, or maybe even later in the online drinks. But for now, thank you very much, Fugro. We will continue with the program, and we move on to the final student presentation, which is by 52. No, it's not by 52 Impact. It's the students that worked for the project Commands by 52 Impact. And the project was now entitled A Strategic Approach for Site Selection of Waste Facilities in Mexico. Mels, the floor is yours. Well, at least you can press the button.